Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. My name is Rohmah Nur Fatimah. In this opportunity, I'm delighted to present our team research about ultrasound-assisted production of cornstarch, process design, and optimization. Working together with my colleague, Ahmad Fawaz Al-Islahi, our research was supervised by Dr. Widyastuti Setianingsi and Dr. Muhammad Nur Cahyanto. Before we talk deeper about the research, I would like to explain the consideration of why this research was conducted. Corn is one of the most important commodity in agriculture for Indonesia. Its production reached the second highest after rice. Even, corn is the Indonesia's biggest export commodity. The world needs of corn is not limited to its fresh form, but also the dried form and its derived products. Widely applicable, non-food industries exploit corn mainly for feed and ethanol production. As for food industry, corn flour and starch are the most popular form. Starch accounts for 50 to 70% of corn flour. This form has a remarkable function in any industry, but specifically to food production, starch are widely used in yogurt and snacks production, as well as sweeteners raw material. Starch production usually require extraction process in which maceration is applied. However, this method calls for a long process time and abundant amount of solvent. Therefore, an alternative method is needed to resolve this problem. Extraction assisted with ultrasound energy should provide solution. Ultrasound-assisted extraction serves a high-speed extraction process and a high effectiveness. Therefore, this method is preferable to replace the convenient method. However, there are several factors affecting the ultrasound-assisted extraction performance, including power, cavitation cycle, and sample-to-solvent ratio. Thus, to achieve the highest extraction recovery, a specified condition is needed. In order to get the optimum condition, an optimization process could be performed with chemometric using box Penken design and followed by response surface methodology. A following evaluation process toward the ultrasound-produced starch is needed to evaluate the applied process. Therefore, the objectives of the study were: first, to evaluate the effects of several independent variables toward extraction yield, to optimize the ultrasound-assisted extraction condition of several independent variables for cornstarch, third, to understand the extraction kinetic and extraction cycle of cornstarch production using ultrasound-assisted extraction, last, to evaluate the ultrasound-assisted extraction produced cornstarch characteristic. In order to achieve the mentioned goals, several sequential works were conducted. Firstly, determination of the independence variables and its levels. The chosen variables and levels were as follows: power of 30, 60, and 90%, cavitation cycle of 0.3, 0.6, and 0.9 per second, sample-to-solvent ratio of 1 to 10, 1 to 20, and 1 to 30. Next, running of the experiments, which consists of 2 blocks. Third, the obtained data were analyzed using ANOVA to obtain the optimum extraction condition. Using the optimized extraction condition, the kinetic study was performed by running the extraction over periods of times from 5 minutes to 30 minutes. Another approach was taken to obtain the best procedure, including the study of extraction cycle. Finally, to evaluate the ultrasound-produced cornstarch characterization is conducted. Then, the extraction process was performed using the following procedures. First, the dried corn kernel was shorted to remove dirt and then grinded. The corn flour then extracted by weighing the sample and adding the solvent. The mixture then underwent the first extraction. After that, the solid were separated from the liquid and introduced to a new solvent. Then, the second extraction was employed. Following this, another solid separation were then performed. The liquid obtained used for the starch collection. A 24-hour sedimentation were done before the removal of the solvent. The starch then transferred into a clean petri dish and dried in a cabinet dryer with 50 degrees Celsius for around 20 hours. The dried starch then grinded to obtain the powder form. Evaluation of the starch, including the calculation of the starch content, viscosity, observation of the starch granules, and particle size. After following the procedures thoroughly, series of data were collected. The chosen factors of the ultrasound-assisted extraction were studied using box-Panken design with duplication. 15 extractions for each block, including 3 center points, were performed in random orders. The responses were relative value to the maximum extraction yield. Following this, the response evaluated using ANOVA. The results showed that 3 factors, including 2 main variables and 1 extraction variable, significantly affect the extraction yield. These 3 factors were then used to evaluate the fitting properties of the developed models. The model equation was as follows. The comparison of the predicted and the observed data resulted in coefficient of determination by 0.88 and the lack of fit value observed to be higher than 0.05. This means the model was successfully explained the observed data and can be used in estimating the optimum extraction condition with confidence level of 95%. From the predicted model, a response surface plot was constructed. Then, using response surface methodology, the optimum extraction condition was evaluated mathematically. The optimum conditions were power of 87%, maximum cavitation cycle by 0.9 per second, and maximum sample to solvent ratio by 1 to 30. As we can see, the cavitation cycle called for the highest level. However, to make sure if this value is fit or higher level is needed, further optimization for cavitation cycle was performed. The results showed that the maximum cavitation cycle by 1 per second was resulted in higher yield. Therefore, this level was chosen for the optimum extraction condition. As regard kinetic study, it can be observed that extraction time will significantly affect the extraction yield. The kinetic study resulted that 25 minutes extraction produced the highest yield. However, it was considered too long. Therefore, evaluation of the extraction cycle was conducted. The result showed that 2 extraction cycles with 5 minutes in each extraction produced the same yield. Hence, this method was chosen. Last but not least, the starch characterization. The evaluation were also compared the ultrasound-produced starch to the commercial starch. The starch content for the ultrasound-produced starch was 73%, and the commercial starch was 89%. The starch content for the corn flour was 64%. However, production using ultrasound can only extract 28% of it. Then, starch particle from ultrasound produced in which passed through 100 mesh was only 88%. In contrast, the commercial starch was 92%. For the viscosity, ultrasound-produced starch also result in lower viscosity compared to the commercial starch. Observation of the starch granule using microscope pointed that smaller size was found in the ultrasound-produced starch, and it have a lot more of the damaged granules compared to the commercial starch. Finally, from all this information, we can conclude that first, 2 main factors, including power and cavitation cycle, and 1 interaction factor significantly affect the extraction yield. Second, the optimum ultrasound-assisted extraction condition was 87% of power, 1 per second cavitation cycle, and sample to solvent ratio of 1 to 30. Third, 2 extraction cycle with 5 minutes in each extraction shows the more efficient method compared to 1 extraction cycle for 25 minutes. Last, the ultrasound-produced starch characterization showed that the starch content was 73%, viscosity of 3084 centipoise, and smaller granule size was observed compared to the commercial starch. I think that's all from me. If you have any further discussion, please don't hesitate to contact me through this contact. Thank you very much for your attention. Wassalamualaikum warahmatullahi wabarakatuh.